Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is ventilation, air filtration, air heating and cooling systems in pharmaceutical manufacturing. This subject is very important since the product gets exposed to surrounding atmosphere. It is necessary to control the environment to protect the product from potential contamination. Materials processed in closed equipment do not have any risk of contamination as they are protected within the contained equipment. But at certain stages of the process, the product gets exposed to outside atmosphere. Such stages include drying in tray dryers, milling, sifting, packing of the product. So obviously it is necessary to control the surrounding environment to the process and product requirements. Let us see the prescription under 21 CFR part 211.46 ventilation, air filtration, air heating and cooling. Adequate ventilation shall be provided. Most of the final stages of the process are carried out in clean rooms in open. All clean rooms are operated in closed rooms and entry restricted. In such closed and restricted areas, natural ventilation is not possible. It is necessary to have ventilation systems. The intent of ventilation is to protect the product against contamination. This is generally achieved by installing air ducts and or higher capacity fans. This also helps providing sufficient fresh air for occupants and removing exhaled air and odors. 15 to 20 air changes per hour is a general thumb rule. But depending upon the number of people working in that area, number of equipment present in that area, volume of the room, etc., the number of air changes per hour may vary. You need to calculate all these aspects while designing the ventilation systems. Equipment for adequate control over air pressure, microorganism, dust, humidity and temperature shall be provided when appropriate for manufacture, processing, packing or holding of a drug product. When the clean rooms are designed to handle controlled room temperatures and controlled humidity conditions as a part of process and product requirement, care should be taken to maintain necessary temperature and humidity conditions during entire process where the product gets exposed to the surrounding environment. Air pressures for each room must be decided during the design of the air handling system. Depending upon the product mix, bubble airlocks, sink airlocks, or cascade airlocks are selected. Bubble airlock protects the core from the external contamination. Bubble airlock isolates the core area from contamination. Sink airlock takes the contaminants into it. Contamination sinks here. It is like a design of a sink under a water tap. Water coming out of the tap goes into the sink and does not spill over all around. Cascade airlock works with decreasing or increasing pressure differentials from each of the adjacent rooms. Dust must be controlled by effective air filtration. Air filtration grade depends on several factors, most stringent being HEPA filtration with a porosity of 0.2 to 0.3 microns. N-1 or N-2 stages may be isolated in 5 micron filtered area because there may be few more steps before it becomes an API or dosage form. Selection of air filtration grade must be scientifically justified. Air filtration systems, including pre-filters and particulate matter air filters, shall be used when appropriate on air supplies to production areas. Raw air contains lots of particulate matter. Some larger particles may be visible and many smaller particles are not visible. The intent of air filtration is to filter off such particles and achieve clean particulate matter free air inside the clean rooms. Pre-filters are necessary to reduce air filtration load on the finer porosity filters. So, for example, if there is a 5 micron end filter, it is necessary to install another coarse filter of 10 microns capacity before the end filter. A 20 microns capacity filter may also be installed before the 10 micron filter to reduce the filtration load further. For aseptic drug products manufacturing, a high efficiency filter is necessary. HEPA is a type of pleated mechanical air filter. It is an abbreviation for high efficiency particulate air filter. This type of air filter can theoretically remove at least 99.97% of dust, bacteria, and any airborne particles with a size of 0.3 microns. In this case also, installation of suitable pre-filters is necessary. If air is recirculated to production areas, measures shall be taken to control recirculation of dust from production. In areas where air contamination occurs during production, there shall be adequate exhaust systems or other systems adequate to control the contaminants. If the temperature is maintained low at around 25 degrees Celsius in the classified control rooms, there is a need for significant amount of energy spent to achieve this condition. So, venting out of such cooled air into outside atmosphere is not economical to operate. In such situations, the cooled air is recirculated. Recirculation is done by filtration of the outlet air through various filters and introduced into the inlet stream. Since the same air is recirculated, oxygen content in the recirculated air may be not adequate. A 10% of fresh air is added into the system to compensate. Fresh air is introduced at the cooling systems. Air handling systems for the manufacture, processing and packing of penicillins shall be completely separate from those for other drug products for human use. Since penicillin products are more potent, it may have incompatible allergic reactions to some people. It is always required to have a separate air handling unit for this type of products. Let us see the prescription under ICH Q7. Section 4.21 prescribes adequate ventilation, air filtration, and exhaust systems should be provided when appropriate. These systems should be designed and constructed to minimize risks of contamination and cross-contamination and should include equipment for control of air pressure, microorganisms if appropriate, dust, humidity and temperature as appropriate to the stage of the manufacture. Particular attention should be given to areas where APIs are exposed to the environment. So in this section, the intent of API being exposed to atmosphere is explained. All the requirements that were discussed earlier are valid here too. For sterile manufacturing, the control of microorganisms is very important. HEPA filter with 0.3 or 0.2 micron porosity is recommended. Also, the air classification of Class A, Class B, Class C or Class D may have to be used. Pressure differentials, number of air changes will also change for each type of air classification. Section 4.22. If the air is recirculated to the production areas, appropriate measures should be taken to control risks of contamination and cross-contamination. So this section has similar requirements for recirculation systems. Let us see the prescription under Schedule M of Drugs and Cosmetics Rules. Under Section 1, the general requirement, the subsection 1.24, Buildings and Premises, prescribes air conditioned where prescribed for the operations and dosage forms under production. The production and dispensing areas shall be well lighted, effectively ventilated, with air control facilities and may have proper air handling systems wherever applicable to maintain the conditions including temperature and wherever necessary humidity as defined for the relevant product. Schedule M of the Drugs and Cosmetics Rules include these requirements for dispensing areas also. Of course, the requirement is implied in other guidelines as discussed above. Obviously, during dispensing activity, the API and other inputs are exposed to the environment. This is the prescription in Part 1 of Good Manufacturing Practices for Premises and Materials under Section 1, subsection 1.24, that is the buildings and premises. These conditions shall be appropriate to the category of the drugs and nature of operation. These shall also be suitable to the comforts of the personnel working with protective clothing, products handled, operations undertaken within them in relation to the external environment. These areas shall be regularly monitored for compliance with required specifications. Comfort for the personnel is again an implied requirement in the guidelines discussed in the earlier slides. These are the useful reference guides to get more information on the air handling systems. Annex 2, Guidelines for Heating, Ventilation and Air Conditioning Systems for Non-Sterile Pharmaceutical Products. Part 2, Interpretation of Guidelines on Heating, Ventilation and Air Conditioning Systems for Non-Sterile Pharmaceutical Products, that is WHO Technical Report Series number 1019 dated 2019. This WHO guide is a wonderful guide with example pictures on various types of clean rooms with necessary air controls. It is simple guide to understand the basic requirement. International Standard ISO 14644-1 Clean Rooms and Associated Control Environments. Part 1, Classification of Air Cleanliness by Particle Concentration. This ISO guide also is very useful for detailed information on various classifications of air quality. I hope that this information is useful for basic understanding. Read again and try to understand the detailed information in the guidelines referenced. Thanks for watching. For more videos, please do subscribe, like and share. Also, Please leave a message in comments box for any further support. Thank you.